So have you ever heard an interesting fact that most of the information in the internet nowadays is transferred through the optical signals, through the light pulses which travel inside the optical fiber? Well, we don't really see it because most of these fibers lie at the bottom of the oceans connecting the continents. But if we really examine accurately these light pulses, we would see that they consist of billions of light particles, so-called photons. And if we were able to work with exactly a single light particle, encode information into it, we can come up with the more secure and more efficient communications. Efficient because we will use exactly one light particle instead of billions of them, and more secure because the behavior and the physical properties of this light particle, they are determined by the quantum physics, which can bring us extra degrees of freedom and make our communications more secure. So my research is about how to generate the single photons in an efficient way and perhaps come up with the applications in our everyday life. Well, here is the question. Do we really have this kind of single photon sources in the nature available? And sure, if we take the small crystals of diamond, which are about 100 nanometers in size, it's about 1,000 times smaller than the thickness of your hair, and look inside its crystal structure, we would see that there will be some defects or impurities. So usually defects is not a good thing, but here these impurities could help us. These impurities can behave like atoms, and they can blink in the way that they can produce the stream of single photons. Well, if you put them on the glass substrate, you would see on the side of the receiver, for example, that the count rate or the blinking rate is quite low. Well, there are several problems. One of them is that it emits photons all over the place, and only few of them can reach the receiver. On the other side, it does it quite slow. What we have done in our lab, we have designed and fabricated an artificial material which is called metamaterials, so here you can see an example of it, and then we placed the nanodiamond with this impurity on top of it. And then when we looked at the count rates on the part of the receiver, we have observed the increase or enhancement of these counts about an order of magnitude. And this is just a first step towards more efficient sources of the single photons, which could help us to come up with new devices with higher efficiency and more secure devices. Thank you.